Hey everyone, welcome to the session on distributed caching system. Distributed caching system, distributed caching system. Today we will break down a simple and efficient way so by the end of the day you will have a clear idea, understanding of how this works and you can design also. Let's get started. Uh, Now that this word is distributed caching system, there's a word caching. Now what does this mean? Caching is a temporary storage device which stores the frequently accessed data which stores the frequently accessed data frequently accessed data, so it can improve the speed and efficiency of, and instead of going to back to the database every time we use the cache to serve the repeated request quickly. Now the question is, why use caching? Because it reduces the database load, and it improves the application performance, and it lowers the response time also. Now, what is the term this distributed cache? Distributed cache. A distributed caching system spreads cache data across multiple nodes. For example, this is a distributed caching system where the data is shared across multiple nodes, node 1, node 2, node 3, and number of nodes. And so there is no single point of failure. It ensures the high availability, fault tolerance, and scalability too. What are the benefits of this distributed caching? It handles a large scale traffic and also prevents a single point of failure, as we discussed. Because if if one fail, then the second node will be taking a part of this the node one, and it also supports the horizontal scaling. It also supports horizontal scaling. How distributed caching works? Now the question arises. There are multiple steps. So to work with a distributed caching system, first is partitioning. Partitioning. It is also known as sharding. What does this mean, sharding? It ensures the it ensures to distribute the data across the multiple nodes. It ensures the data to across multiple nodes. We use partitioning in three ways. First is hash based. Second one is range based. The third and last one is consistent hashing. Now, what does this means? Hash based. It uses a hash function, as in this name we can see hash. So it uses the hash function to assign keys to nodes. Range based, it stores the keys. It stores the keys in a specific range per node. Consistent hashing. It is better for handling the dynamic scaling. Now the step two is cache invalidation and expiry. Cache invalidation and expiry. Cache invalidation and expiry. Cache needs to remove outdated data, so we use TTL. Now, what does this TTL? TTL. And another one is policies, also known as eviction policies. Eviction policies. TTL. It is time to leave. Time to leave. It is automatically removes the data after a set of time or after a certain time. Policies or eviction policies, it is the most commonly used is LRU. So it is LRU means if the recently used data is has been removed first as compared to the aged one. The third step is replication and the fault tolerance. replication, and fault tolerance. How you will handle this replication and fault tolerance? Okay, to ensure the high availability, data is replicated across multiple cache nodes, as we can see in this diagram. That data is replicated across multiple cache nodes. If one node fails, another can serve the request. Now the step 4 is consistency and synchronization. Consistency, consistency and synchronization. Consistency and synchronization. In distributed caching system, keeping data consistent is a challenge. So we use write through caching, write through caching. Another way is write back caching, write back caching, and the last one is quorum or quorum based consistency. Now, what does this mean and how they works? Write through caching. Write through caching it updates the cache and database together. Updates the cache and database together. A write back caching. It writes the cache first, then asynchronously updates the database. Whereas quorum-based consistency, it ensures the data is synced across replicas. Now there are different strategies of caching, so we can integrate the caching into an application. Because at last we have to do this only. Caching strategies. Cache aside, and this is the most common that we use. Cache aside, uh, the application first checks the cache. In this, the application first checks the cache. If data is missing, it fetches from the database and stores it in the cache. The another one is write through. Write through. What does this mean? Every database write also updates their cache. In simple words, we can say that. Third is write back. Write back, and the fourth one is read through. Read through. Write back. What does this mean? It writes go to the cache first and are later pushed to the database. As same as we have discussed here, write back caching in consistent synchronization and read through. The cache fetches the data automatically when they are queried. Now there are different technologies in are available. So which of them are picked? They are picked according to their strengths and uses. So we can discuss here also. There are multiple technologies that we we have generally is technology, and there are multiple features of them. For example, the first that we commonly use is Redis and Memcached, Hazelcast, Hazelcast, Apache Ignite. What is the air features? Redis is fast in memory. It is fast in memory and it supports clustering and persistence. Memcache is simple key value stores and it is high speed lookup. And Hazelcast is JVM based. It is JVM based and it supports the distributed computing also. And Apache Ignite, it is SQL querying and it also is memory centric architecture. For most of the web applications, Redis is the most and the best choice because it supports clustering, replication, and high-speed transactions. Uh, let's take a scenario of a real world example. E-commerce website. Uh, a e-commerce website where caching can improve the performance. How? A user searches for a product. The application checks the distributed cache. If the product is in the cache, it serves instantly. If not, then the database queried and the result is stored in the cache for the future use. Now, mm, just guess what are the technologies that they have been used in this. e-commerce website is Redis for the clustering for caching, and cache a site strategy for storing and side by side, consistently hashing for load distribution. Now the main part is comes is deployment and scaling considerations. When deploying a distributed cache, we have to keep the best practices in mind. For example, there are some of the best practices, which is auto scaling. Auto scaling, it adds the nodes dynamically. Load balancing, load balancing, it distributes the request efficiently. Monitoring and logging, monitoring and logging, it uses the Prometheus and Grafana to track cache performance. And the last one is security. It implements the authentication and encryption for the data safety. Now let's conclude that what we have done till now is takes a complete breakdown of how to design a distributed caching system and remembering how the caching is a powerful tool to optimize the performance and scale applications efficiently. What are the key takeaways that we have to remember is caching reduces the load and speeds of the responses times, and distributed caching ensures the scalability and fault tolerance. It uses the proper partitioning or sharding, eviction policies, TTLs, and replication strategies and synchronization, and there are many other things that we have discussed in this video. I hope this section was helpful. If you have any questions, drop them in the comments. Don't forget to like, share, and subscribe for more tech content. See you in the next video.